interject. Right. So, welcome both of you to our Avionics Altimeter webinar. Be hosted today by Mark and Frank. You guys know them both well. And of course, the obligatory contact page for all the main team for FNL in case you need to reach out to anyone. And then I will hand this over to Frank and Mark. Who is starting?
Well, good afternoon, everyone. Welcome to the Altimeter Avionics webinar. Of course, what we're going to be using during the competition are going to be the COTS altimeters. That's a commercial off-the-shelf type altimeter that are available at your local or distance rocket vendors. Switches will be used to turn the altimeters on and off. We're going to be going by the talk about the power supply usage, which is very important, and the tracking your rocket when you cannot see it anymore, and avionics hardware. The term avionics is usually used to describe electronic components that control the flight of a vehicle. Of course, all the altimeters are used for how high the rocket goes or for tracking. This does not include any payload or challenge components, of course. These are not affected by the flight of the vehicle. The vehicle should be designed so that you have a successful flight and stable, of course, without the payload. Although sometimes things happen, the term payload is not the same as the term avionics also. Payload is probably more or less described as in the Moon and Mars challenge. Avionics are specifically for the operation of information, what the rocket does, and deployments. Next, please. COTS altimeters, commercial off-the-shelf, means what I just repeated. You cannot fabricate, program your own altimeter for ejection events. Altimeters are a small electronic device. Some are barometric pressure type that records the altitude of the rocket at all times. Advanced altimeters have an additional feature, which is a accelerometer. I know for a fact that some altimeters are accelerometers as they ascend the rocket, and they register over to a barometric type pressure for deployment. Altimeters trigger their ejection events. Black powder usually is triggered by the altimeter for parachute deployment, and especially for a dual deployment configuration. Altimeters also are needed to record your flight apogee. And apogee, of course, is your altitude, the highest point your rocket goes. Altimeters usually contain a drobe function and a main channel, which suggests a redundant, otherwise known as a backup altimeter. If you want to use two altimeters side by side, just for a backup. You get to program your altimeter to trigger mostly at apogee, which is usually a default on the altimeter. You may want to program it a second or two after apogee. Depends on the operation of your rocket. And also ensure you have to understand the GUI for your altimeter. Your mentor will provide and instruct, and of course assist with connecting your ejection charges in pre-flight. We strongly suggest that, just be on the safe side. You should test your altimeters in a vacuum chamber, which works very fine to test your apogee and your main, wherever you had it programmed at. Now I have to answer the door. Mark?
Okay, where were we? Sorry. COTS altimeters. All right, so your altimeter is right. Usually contain a drogue and a main channel. Hopefully we'll get to some pictures of what altimeter looks like here in a minute. And then you program your altimeter. So keep in mind that you're the one that programs it. It's not just automatically programmed for you. So you need to understand how the altimeter works and how to connect your altimeter to your GUI to program your altimeter. Your mentor will provide, instruct, and assist you with connecting your ejection charges prior to flight. Usually, if you have a test flight or if you have a good mentor or a launch site near you, this can be practiced and instructed ahead of time prior to launch weekend. However, if not, if you don't have those resources, we'll do that for you and teach you how to do that on launch weekend in Wisconsin. Keep in mind, you should also test your altimeters in a vacuum chamber. So there's videos online, there's resources at rocketry websites and channels that'll show you how to both create a vacuum chamber and what to test in your COTS altimeters. Next. So some simple altimeters. So you see on the right, there's a picture of a perfect flight stratologger. And then a featherweight Raven 4, which is, I think, outdated. I think featherweight now has a new Raven under a different name. And then altimeters can be used for a single deployment, apogee main, or can also be used for, or more typically used for a dual deployment, deploying a drogue parachute at apogee and a main parachute at a lower altitude. I'll let Frank take over back here on the rocket speed and Mach information. Go ahead, Frank.
All right, here I go. If a rocket speed is anticipated to approach the transition Mach, select only the controllers which is Mach-proof in-hibited to prevent recovery and deployment while under thrust. That means that your altimeter can almost brown out, get confused by Mach speed, and deploy at before it reaches apogee, and you end up with a big disaster, actually. Next slide. Oh, there's additional features on altimeters, on the COTS altimeters. You have barometric sensors, which should be handled quite sensitivity on the altimeter, where you store it and how you handle it. Altimeters have a 1-axis, 2-axis, and 3-axis operation. Gyro sensors, usually 3-axis. Of course, the Mach inhibitor is a usual feature in most altimeters these days. That's why we kind of go away from off-the-shelf type altimeters. You have to be really familiar with the operation of altimeters for Mach inhibited lockouts. Selectable barometric and accelerometer, and geo-triggered apogee, drogue, and apogee deployment. Of course, the main deployment of a barometrically sensed altitude should be the primary function of the altimeter, and excessive flight data recording, telemetry, as well as the tracking in some models.
Oh, if I could also mention, if we're on back on that previous slide. So that's the Altus Metrum model there. Altus Metrum is the company that makes quite a number of altimeters. They're usually high end. If you notice the little brown square in the middle there, that's your GPS sensor. So the some altimeters combine a GPS tracking feature in them. So again, that's one of your cost requirements, is to have an altimeter and a GPS. So keep in mind, you can buy a combined altimeter / GPS in one device. Just wanted to point that out.
It's a very, very nice unit too. I like it. Here's a typical wiring of a, looks like an RC3 type altimeter in a way. Notice that the to the left you have your battery, and your battery connects to your altimeter, but it doesn't mean your altimeter is on, because it is broken through a switch through the circuitry. Switches are always required in your rockets to turn on and off the altimeter, only at the launch pad, please. Now, of course, the altimeter operates the drogue chute, which is to the left, which is wired to the pyrotechnic, and the main to the right on charge number 1 is usually the main that you program at anything above 300 feet AGL. And of course, this is a redundant system. It has 2 altimeters, and me flying rockets the way we do, I do use redundant systems all the time because sometimes the other altimeter doesn't function right, or you forgot something to hook up. So dual altimeters is a good thing to use.
And then I'll also note with the diagram, notice the diagram is actually spatially correct, which means that this is how the electronics will sit inside of the rocket. The rocket could be imagined left, right on the screen. The drogue is in the back of the rocket on the left, and the main is in the front of the rocket on the right. And then also notice your switches are extending left, are up and down, or to the outside of the rocket on either side of those altimeter bays.
Yeah, avoid putting your drogue in the we call it the payload section or sustainer section. We always want the drogue in the booster section. That works the best. And the main in your sustainer section, the front of the rocket. Next slide. Some common brands are not extant on the list. We have the Featherweight. It's a Raven altimeter, and they do have a new one. I can't think the name of it either. Mark, the Altus Metrum, very useful and versatile altimeter. Perfect flight, very dependable altimeter, very easy to use, very easy to download the information. MissileWorks is a very well-known company, and a lot of people use these in high-power rocketry. Works very well. Of course, we have a link right here for your information on. I don't know if you want to. Is that hot? Can that click?
Can you drop that link in the chat, Rob, and then we'll move on with the presentation?
There you go.
Link's broken.
I'm not sure it's live.
Yeah, okay. That's just information. Next, please. Avionics switch is very important in your rocket. You make sure they operate every time you turn on your electronics. Each altimeter must be on a independent circuit. That means that it has to have independent altimeter, independent power supply to your altimeter also. Each altimeter must have an external accessible switch. Your altimeters cannot be turned on until the rocket is vertical and at the pads. Please remember this all the time. Do not turn on your altimeters at the prep table at all. The switch is typically accessible on the switch band, which also contains your vent holes, which are in the avionics bay section of your rocket. Go ahead, Mark.
Sure, I'll take over here for our next slide. Avionics switches. Some considerations for your switches. Use switches that are resistant to changes of state under G forces. So if you think about, right, say a toggle switch, for example, when a toggle switch is accelerating when your rocket takes off, there's a chance that the toggle could untoggle, right, and turn itself off just using the force of gravity and acceleration. So you don't want those switches. Or, maybe you decide you want to orient your toggle switch down because it's going to come up. Keep in mind that when the rocket turns over on the descent, the forces could also turn the switch off. So you want switches that cannot be affected by forces in flight. Do not rely on twisted wires to complete the circuit. That's kind of the old school method. Guys will kind of just stick their battery wires out the side or something, and then you kind of splice the two wires together, and that's a switch, and then you'll tape it down to the side. Not really advised. Some old school rocket guys still kind of do that as their switch method. Screw down switches or magnetic activated switches are preferred. So you see some images there and below. Frank had mentioned some companies earlier. MissileWorks makes altimeters. They also make switches. Usually a company, if they do make an altimeter or a tracker, they'll also make the equivalent or, give you some options for switches as well. They're not included when you purchase the altimeter, so make sure to go look around within their website. Featherweight also offers a screw switch. You see there in the middle. And then Featherweight also offers a magnetic switch. And you can see the size of the switch there relative to, I believe that's a dime. They're pretty tiny switches. Magnetic switch works on the principle of if you wave a magnet over top of the switch, goes from on to off. And if you wave the magnet the other direction, it goes from on to off. So they're pretty cool. Sometimes they're a bit finicky, so you kind of gotta, where you position them on the surface of the rocket is kind of important. So if you're looking for something, flashy, and you want to try those magnetic switches out from featherweight, or you're running a featherweight GPS or a featherweight altimeter, maybe pick up a couple of those magnetic switches and check those out as well. Avoid bat handle, toggle, like I said, and slide switches, right? So slide switches is kind of the one that just kind of slides up and down. Those will be affected by forces in flight. And you don't want your altimeters accidentally turning off in flight prior to parachute release. Next. Avionics power. So each altimeter must have a dedicated power source. Power is not shared to other devices. So you can't have two altimeters running to the same battery. They each have to have independent batteries. Understand your power source your altimeter requires, right? So make sure you understand some altimeters run off 9 volt, some run off of 7.2 volt, lipos. So just make sure you understand the power range, that you're giving it enough power to get its, performance functions, but that you're not putting too much power through it that you're going to short it out or burn it out. Remember to secure your power sources for high G loading. And again, there's some pictures of batteries there. There's a LiPo battery on the left and a regular 9-volt battery on the right. Unfortunately, we don't have any pictures of how to secure your battery source. Some cheap kind of old school methods. You can zip tie the battery to the board. You just kind of stick it on the board. We've seen some other types where you use Velcro, for example. You put a Velcro piece on your battery. You put Velcro on the board, and you kind of stick those two together, and it prevents the battery from shearing in flight. Shear is the sliding motion. You can also purchase, there's battery clips and battery holders that you can purchase, again, from many of the vendors, Missile Works or Featherweight. If you poke around their websites, you can get battery holders that retain the battery in all, like 3 directions, X, Y, and Z, plus and minus, so 6 directions. You want to make sure your battery doesn't fall or move or disconnect from its clips in flight. Next.
Yeah, if you attend the recovery webinar, there's a couple ideas on how batteries and altimeters are mounted, of course, 3D printed, and what Mark explained too.
Go ahead, Frank.
The new Raven is called the Bluetooth Raven. You can turn on that altimeter on your phone using a Bluetooth app on your phone, which is kind of convenient. That's another different type of switch that they've used. Your rocket is required to have a tracking device in the competition. Aside from the challenge of tracking the Moon Challenge, there is also a variety of simple plug and play GPS type devices that are offered by the altimeter companies mentioned previously. Always look further on into the altimeter company of they usually sell convenient type accessories for your altimeters to operate and to function properly. Of course, ensure to test your tracking devices and understand its operation. Some tracking devices may not track your rocket if it's over a hill, over a ravine, or a thick tree line. So I always tell everybody to watch your rocket where it lands. That's most important. And if you have a direction where your rocket lands, walk in that direction. You'll end up picking up the signal again once you go past a ravine or a tree line. And sometimes power lines will interfere with your tracking device also. Next, please. Radio frequency considerations. We try and work with license-free operations, which is the Raven usually uses. The Featherweight to your right is a very, very convenient device. We have a lot of flyers that use this. I was up in Canada. A lot of students were flying over 10,000 feet and landing in conifer trees like 5 miles away. And they did find the rocket, which was incredible. It's a very, very useful tool. Of course, the components you have to take care of and watch where your rocket comes, of course. Anything greater than that the featherweight amateur band operation, you have to be licensed under the FCC. What is the frequency, Mark? Do you remember? 933 kilohertz or something like that? Oh, it always changes all the time. Next,
Yes,
please.
900 something.
Yeah, all right.
I think we have a slide on it actually. There you go.
There it is. 915. Okay, 93. Okay. Radio frequency considerations. This is license-free type frequencies, which you can operate in the United States, of course, without a amateur license. Amateur band requires a U.S. amateur radio operation license and a technician's class at a minimum. You can take all these FCC radio ham license online. It's not too difficult. FNL suggests that license-free trackers prohibits transmissions that exceed 250 milliwatts.
So keep in mind while you're looking for a GPS tracker for your rocket, basically some of them will require you to have a license and some of them will not. So we suggest you look for the ones that do not require a license. Those are the easiest to deal with. That way we're not breaking any laws in flight. If you decide you do want to go with one that requires a license, then it's on your team to make sure that you understand how to acquire that license and pay the fee for that license, and someone on your team has a license.
Next. Oh boy. These are just the tracking frequencies that are all locations in the United States. And I can't even read that.
Quite a few.
Yep.
And only a
Next.
few in here that any amateurs should be allowed to use. So
Right.
be careful, everyone.
Yep. Avionics tracking. You have the flight components of the GPS antenna in this featherweight type altimeter to the top right. And of course, in the middle, you have the Altimeters. That's a very, very good tracking device. And we have the I don't know what that is on the right. No, the featherweight GPS. What is that on the right? Is that a
The one in the lower is
that's
made
an
by
apogee.
apogee components.
Apogee.
Apogee
Yeah,
simple-
apogee. Yeah. That works okay if your rocket's within a couple hundred yards. Otherwise, hills, trees, and really knock it out. You got to watch where your rocket lays. Of course, you have tracking transmitters, and of course, most important part of your tracking operation is the battery power. Sometimes you might be at the pads for an hour, maybe 2 hours, or standing in line. Make sure that you have your altimeters switched off while you're standing waiting in line. Have it switched off when you're at the pad until you're ready to fly. Turn all your power on and all your components is a good idea.
Also make sure during procurement. So sometimes when you go on a website such as Featherweight or Altimeters, when you make a purchase, you may only be purchasing the transmitter and not the receiver. So
Right.
make sure you get the complete set. You need two components, right? You need the component in the rocket, and you need the ground component on your hand. So make sure during procurement or budgeting that you're allocating money for both. Some vendors sell them as a package together, and some do not. So just make sure you're clear on that when you're selecting your components.
Also, a word of caution on altimeters. Some may require you to have it in a certain orientation, like horizontal or vertical. Most of them are vertical, especially the featherweight. You must have that in a vertical position for it to read the rocket going up as it ascends. It won't even turn on, it'll turn off, actually. A lot of people don't know that. Ground components, you have a receiving antenna that Mark was talking about, which is part of one of the intricate tools you have to get with the transmitter, and you have a receiver, computer or a laptop or cell phone, which the featherweight uses on your cell phone. It tells you the direction, which way your rocket is, tells you how high it is. Also, you can get an app that actually talks to you, which is really kind of cool. Software application, always update your software for that, and on the firmware on your altimeter and your tracker is a very good idea. Next, please. This type here, they still sell this on Amazon. They work very well, this type of tracker. It's an RF tracker. A lot of high power rocket people use this. They don't sell it anymore. They went out of business, but there are plenty of people that have them. Matter of fact, FNL, we carry a few of those if required to use, and just in case we can't find your rocket. We do have one at the launch if you need one, but you must supply your own tracking device. Of course, we have the Altus Metrum that we were talking about, and Apogee components. We have these hot links here that shows where the altimeters can be purchased at and who are the vendors. Go ahead, Mark.
So the avionics bay, the hardware. So we talked about all the components, all the electronic components for a successful flight. But where do all these components go? Where do they all sit in your rocket? Well, they sit in what's called the avionics bay. So you can see the diagram. The avionics bay sits in the middle of your rocket, typically. So as we mentioned earlier, right, your drogue parachute sits in the booster section, which is on the right side where the fins and the motor are. That's your booster. And then the other side of the electronics bay is called your sustainer. That's where your main parachute sits, as you can see in the diagram. Next. So avionics bay hardware, your sled, your avionics actually sit on what's called an avionics sled. And then your sled will sit inside what's called the coupler. You may fabricate your sled to integrate into the rocket. So a lot of these altimeter suppliers, such as MissileWorks, they also sell an avionics sled. I think they 3D print them now these days. The easiest 3D sled, which you might be able to see in the bottom image or maybe another image, is basically just a piece of plywood that you kind of just screw your electronics components to. You can see in the black image there. I think that's just like a piece of fiberglass that you're kind of screwing all your electronics to. You could also go and buy a COTS altimeter bay, and it'll be a 3D printed kind of sled. You could also 3D print your own sled, right? If you guys have 3D printing capability at your school, look at and kind of research some existing hardware, or look at the MissileWorks site and see what kind of sleds they offer, and then decide, hey, maybe we want to make this ourselves. And then your switch and vent band will be centered outside the coupler. So that's another component, hardware component of your avionics bay. So you see the white band there. Rob can highlight that white band, the white strip on the coupler. That's your avionics bay. There you go. And then the green part is your coupler. So that's the hardware that sits between the booster and the sustainer tube. I don't know if we have more on that. If Frank wants to add anything to that.
Yeah, that whole green part is where your avionics would sit, and of course you have the switch/vent band. I don't know if that's discussed later on. The altimeter needs to breathe, so you need a ventilation hole for it to measure the vacuum from the inside to the outside as the rocket ascends and descends.
Next. Oh, there we go. So some sleds we were just talking about. You see the blue image there in the middle. That's one of the COTS 3D printed sleds that you can either go and buy, or you can decide to reverse engineer and 3D print one yourself. The blue 3D printed sled is kind of nice because it has a feature there already pre-existing for your switch. So you see the little hole on the bottom. That allows you to align your switches with your vent hole that we talked about in the previous slide. So this sled will actually only sit in half of the avionics bay. This hole here in the middle, Rob can highlight the hole in the middle of the blue sled, or down at the bottom.
Switch.
There you go. That's where your switch will go, and that'll align with the center of the avionics coupler. So your altimeter, and then you can see on the back side of that sled as well, there's a mounting feature for a battery. So same with the blue sled on the back side. That's where your 9-volt battery will sit inside of that little housing. And then I think there's a door that actually screws on top of that, and you can close that all up. Yeah, the door is right in front of it there. Yeah, that's the door that you screw right on top of the the 9-volt battery and keeps that secure inside of your avionics sled. So feel free to go and look online if you want to buy one. Make sure it matches the diameter of the rocket, because there's 2 rods that run through that sled, and those rods have to align just like these rods here. And you can see all the other rods and all the other altimeter bays. There's a certain diameter or width that you want your rods to fit. So some other sleds, like we talked about, there's a fiberglass sled in the upper left. It has 1 altimeter piece on it, and it's halfway into the avionics bay. In the lower left, there's a black, looks like a 3D printed black sled. So you could just have a simple, like a plate. It doesn't need to be a fancy 3D printed thing. You can make it out of, there's PVC tubes there for the rods. Some people use a little metallic tubing for your rods. And then in the center lower, there's another avionics sled with a couple of components on top. And then there's also, I believe that's a COTS 1-2 on the far right. The gray components are bulkheads that sit outside of your avionics bay. So it's basically an avionics bay without the coupler. So the coupler is removed to kind of allow you to see the interior components. But this is what a completed and assembled avionics bay would look like. You would have bulkheads on either side. Your sled sits in the middle, and all your components sit on the sled.
Yeah, you have to make your avionics, accessible, easy accessible, so you're not pinching your fingers or wires as you're putting it together and programming it. Also, just a note, your LiPo battery is the same width as a 9-volt battery. And if you have a 9-volt battery compartment, all you need is a filler to fill that area. But the LiPo battery is the same width as a 9-volt, just for a tip.
So as we mentioned, some more 3D printed sleds. So most of the schools these days, even the tribal colleges or the gateway teams, feel free to print your sled if you've got 3D printing capability at your school. So that's just some more examples of some 3D printed sleds. You see the one on the left has 2 screw switches. Actually, it has 3 switches in total. There's a black toggle, like a turnkey switch in the middle. And then there's 2 screw switches on either side. But ironically, there's only 1 component. There's a telemetris. So I'm not sure why there's so many switches or what they were planning on using the extra switches for.
Yeah, just an example.
But that's just some ideas how to put your sled to work for you. And then we can see the same sled in the middle we saw on the previous slide. This is a kind of a COTS. I believe you can buy this. I'm not sure which vendor sells this. And then just integrate all your components on it. And then the one on the right is another. The blue sled is actually, it looks like a nose cone bulkhead with a GPS, because there's no bulkhead on the top side. So keep in mind, you can put electronics in your bulkhead, in your nose cone. And then the one on the right has 2 bulkheads on either side, and these are tiny. So look at the size of the pen, right, in comparison. Maybe these aren't the best examples, because this year's challenge, you guys will have at least an 8-inch diameter airframe, so you'll have a lot more room, right? I mean, these guys in the examples are this big, right, like an inch or 2 across. You're going to have an 8-inch diameter, so you're going to have a lot more room to play with. So maybe you don't need a lot of length for your avionics altimeters. You could basically stack, 4 or 5 GPSs across an 8-inch board, an 8-inch wide board, and therefore you're reducing the amount of your avionics sled length in the overall direction.
Also, you can also, if you don't feel like 3D printing a sled, avionic companies that supply the altimeters, they do have access to 3D print your specific altimeter for your diameter of the rocket, if you wish to. Next. Mounting considerations. Of course, tracking devices require RF transparent airframe in vicinity of antennas. Tracking devices will not go through carbon fiber to track your rocket. It nulls it out. No metal or aluminum steel around your avionics bay where you're telemetry system is. No metallic finish, paint, or heat shrink covering around the altimeter area where we have your tracking device. Your avionics altimeter will work, but your tracking devices will not work. Some nose cones, depends what kind of kits you have, are made out of carbon fiber, and some nose cones have capable of head-end deployment. Tracking devices will not work in those nose cones at all. Barometric sensors require a free airflow to operate, like we mentioned before with the vent hole. Add ports and vent holes into the avionics bay where the switch band is at, like we mentioned before. Of course, always read the handbook and instructions for the altimeter on its operation. I think we do supply one of these books for high power rocketry. I'm not sure if
I think we supply both of these books to all teams, all new teams.
okay, all right,
New teams.
new teams, okay. And of course, very bottom one is very important. See the FNL competition handbook, please. Next, please. Mounting your avionics bay and hardware. The avionics must be mounted in a rigid area where it will not move at all during flight, during takeoff, during apogee, and during deployment. Accelerometers and gyros require solid mounting for error-free performance. If your electronics are loose and it feels a sudden jerk, it will not operate properly. It may brown out. And also when you're at the pad and you're turning your switch on and off too, to the power supply, it can also brown out too. If any of that happens, please bring your attention to the launch pad manager. All wiring should be soldered and or crimped to ensure connections. I can't read that. Oh, connections are good under G-forces. I do recommend using a particular size type of wire. Is usually a stranded number 18 or 22 wire. Try to avoid using solid wire, because if you are putting your avionics together inside your sled several times, sometimes that wire becomes brittle and it may break off. So stranded wire is a very resilient type wire to use for your avionics. Yeah, it looks like a mess, huh?
Yeah, this is an example of kind of what not to do with your avionics bay. So you can see the wires are kind of all over the place, right? It gets a little messy to troubleshoot, right? So say you're out on the field on launch day and it's like, hey, my altimeter's not powering up. What's going on? This would take such a hassle to track down that problem. It'd be like, well, is the wire from the battery to the altimeter the problem? Who knows where it runs? It's not even labeled properly. So make sure to color code your wires as well. There are more colors than red and black. You see there's two colors there. You can buy different colors of wire, blue, yellow. Have a system in mind so you guys can easily troubleshoot and see where your wires are running and which one's the problem. And same thing with the image on the left there. We see the two components on the board, the board's good. The component placement is good. It's just the wiring runs a little long. It's kind of tapered around. Try and keep your wire connections as short as possible, so they're not snaking around, especially when you go to assemble this bay. The one on the left, when you slide it into the coupler, that wire could get snagged somewhere. It could get snagged on the bulkhead. It gets pinched and then it breaks off. Or it gets snagged on the coupler itself when you're pushing it inside. And then that maneuver or motion itself pulls the wire out of the altimeter. And then you don't know because you've just sealed it inside the bay. So as an example of those.
Yeah, also some of the switches that you mount on your switch band don't have a very shallow clearance sometimes when you push your altimeter in. Like Mark was saying, wires may get hooked on it. A good plan is to actually tag your wires, especially your drogue and your main wires, so you know you're going in the right direction. And always put an arrow up on your altimeter bay somewhere on your sled, so you know you're going in the right direction.
Yeah, you can use the board and you can create labels. You can say drogue this way or main this way, and you can also get little labels you can put around the wires that help you distinguish which wire goes which direction when you're prepping your rocket for flight. This here is just an example of another kind of avionics setup. This one's a little more professional. I'm not even sure what that component is, Frank.
Oh, that's a yeah, it's a long name.
I think we pulled these from the internet. Is that the RDAS?
No, that's close, but it's not. I know what you mean. Yeah,
Yeah,
they're about that.
some of these older components, and you may see some electronics out there that aren't in production anymore. Some of these companies have kind of gone by the wayside. So you may see images or you may reference a device that they don't make anymore. But this is a not bad. This is a decent altimeter setup, electronic setup. You can see your rods running the length of the coupler, and then this yellow sled here, the yellow device is attached to the rods, and the wiring's all kind of bundled up in this harness. And notice the wiring also has a white quick connect, so you can use that as well to kind of quickly disconnect your wiring from the external to the bulkhead. And then you can see the switch here on the top in the center of the yellow that will line up with the vent hole there on the white band we saw earlier.
Avionics summary. Mount avionics to prevent unintended operation. Ensure the RF transparent airframe for telemetry and tracking. Make sure secure electrical connections. Always use solder. Try and use a solder connection if possible. Sometimes the altimeters have Phoenix connections. Make sure they are tightened and retightened down. That's one. That's why I'm telling you to use stranded wire instead of solid wire, because if you tighten it down too tight and you're moving wires around, that's a part where it gets a little brittle and it could snap off either during installation of your avionics or during flight. Allow the airflow to the barometric sensors. Please read the instructions on how large the holes should be and how many should be in the switch band. Consider redundant flight controllers. Very good idea. Your rocket will always come back safe. Time phase redundant charge to fire after the primary charge by
that. So if I can expand on that one,
yeah, go ahead.
So do not program your altimeters. And we see this in your fly sheets when you guys submit fly sheets. We ask for how your altimeters are programmed. Do not program your altimeters to fire at the same time, because you should be sizing your ejection charge for just the bay itself. If they fire at the same time, then you're providing twice as much force than is required or needed, and you could damage the rocket at that point. So you want to step your ejection charges to fire, have a delay, and there's a feature usually in your altimeter programming. It'll say 2-second delay or 1-second delay. So make sure one of your altimeters is programmed to fire after the other altimeter.
Right. It's not so much that the altimeter might not work. That's the issue. It's not the part where you think that if a altimeter works and the deployment charge isn't strong enough, that's not going to save your rocket. The redundant part of it is that the altimeter will go off when one is not working, because once your rocket is separated to a certain point where the parachute is not out, your second altimeter will not generally push out your recovery, because there's no pressure for it to push it out. So it's actually, the redundancy is for if one doesn't absolutely operate at all and the other one does. That's the point of using a redundant altimeter system. I've seen that happen many times where the parachute came out, there's like maybe 5 feet of cord hanging out and the parachute's hanging out there like a handkerchief. Then the other charge goes off and it blows by the top of the recovery system and it still looks the same. So yeah.
Thanks, Rob. So to finish out there, test what you will fly and fly only what you will test. So make sure to test all your components, test your altimeters, test your GPS tracking. If you can do a ground ejection test, you have a mentor with black powder and you can handle that safely. Do a ground ejection test to make sure you know how much black powder to eject out of your rocket, and to know that your rocket is strong enough to survive the ejection event. And then ensure your deployment charges are adequate to deploy drogue in main. So there's calculators you can find online. I believe there's some support in the FNL competition handbook. One of the appendices talks about ejection charges and how to calculate how many grams are needed per volume.
And ta-da, there we are. Thank
Perfect
you,
time.
everyone, for listening. Any
Thank you all.
questions?
Not immediately, but definitely soon.
No problem. Launching a rocket and the motors that we load and put in your rocket is the easy part. The hard part is the recovery part. That's the challenge part. Is the recovery.
Jennifer, any questions or?
I had one. I was trying to think of how to like word it. I think it's related to like the nose cone. Because I noticed in the schematic that suggested where to put the avionics, where to put the section in the avionics bay. How does that connect if you were to move that to the nose cone, how does that connect to like one of your chutes?
So this webinar is kind of just some general information about avionics. Not all of it is applicable to the challenges. So this year in particular, we want your avionics bay to be in the coupler section in the middle. Rob, can you go back to that slide that showed the rocket with the bay? So we mentioned some of the nose cone, altimeter, avionics stuff. That's more for maybe a different year's challenge. So you can see here where we want your electronics and avionics. So your altimeters to eject parachutes will sit in the middle of the rocket between the drogue and the main.
Okay.
The only thing you could probably put in the nose cone if you'd like is your GPS tracking or your tracking device.
Okay, that helps.
This year. I mean, if you were to
Yes.
go out and build your own rocket, feel free to put your altimeters wherever you'd like to put them. You could put them all in the nose cone, and then you'd have to figure out how to wire all that to eject your parachutes in the one direction.
Okay, thank you.
Is she referring to the Moon or Mars challenge? Is that one?
I think we just mentioned the nose cone electronics, and I think they're thinking about putting their altimeters in the nose cone.
Right.
Trying to deploy. Like
For
any
deployment.
hardware. Yeah, any
So if you-
electronics they might need for that. That's what
Yeah,
I'm
so if
thinking.
you're talking about a payload deployment up front, you could use the nose cone and deploy backwards. You're more like that would be more like pushing the payload into the rocket. Do you understand? Because if your electronics are on the left side where the nose cone is, and you have an ejector, it's going to push the payload into the rocket to the right.
Right, yeah.
So kind of what you want is the opposite, right? Like you want your payload electronics to sit on the right side and push the payload and the nose cone to the left.
Right, okay.
So that would require another avionics bay or
And that's part of the challenge. We want you guys to figure out like how do we create an electronics kind of bay, and it don't, just because we describe this bay here for you, this is a standard avionics bay in the middle, doesn't mean you have to have the same standard avionics bay for your payload. There are unique and one-off types of avionics configurations that you can use for your payload. So that's up to every team to do the research, look on the internet, and propose something to eject your payload.
you could satellite your deployment too through that avionics bay to your nose cone compartment where your lander is too. And satellite, I mean a wire running from your AV bay along the airframe, inside the airframe. Yep, to right there to pop your lander out.
Yes, that makes sense. Yeah. Okay, thank you.
And of course, you got to think about your main too for your rocket.
So Frank gives you the answer to the challenge. I'm going to deduct marks from your team. So
Oh, is that what you meant before, Mark?
please come up with your own unique solution.
It's not the most elegant solution you could use. Awesome.
Thanks, Jennifer.
Well, if you guys think of any additional questions, feel free, send them to me. I will send them to Mark and Frank, unless we already have it as a common question that I've received, and then I can handle that answer for you. But as always, thank you guys for joining us.